It's very nice to be with you in this nice event. So today I will talk about a selection of novel blockchain-based applications. As you already know, I am part of National Institute of Astrophysics, Optics, and Electronics. So the outline for this talk is it's talking a lot of blockchain, but I will start with the beginning. And I named this beginning the distributed electronic money. So I will try to explain all of you how this started, and then I will introduce some attractive blockchain properties that allows blockchain to be part of a very nice application solutions, such as supply chain management, healthcare applications, and electronic voting. And finally, we will try to make some final remarks. So all electronic money models proposed before 2008 were centralized. And in 2008, Satoshi Nakamoto published a seminal paper titled Bitcoin, a peer-to-peer electronic cash system, where Nakamoto combined some nice ideas that were previously published, and with that, define a distributed electronic money system. So as you can see in this image, we have a blockchain overview. So how blockchain works? Basically, a user performs a transaction, and this transaction will be propagated in the peer-to-peer network. So the idea is that each node can verify that the transaction is correct. If this verification succeeds, then the transaction will be part of the mempool of the node. So this mempool is just a pool of transactions, and eventually the miner will include this transaction in a block. So if the miner is lucky, he can answer the cryptographic puzzle associated with the block. And then the block will be mined and then introduced to the blockchain. So that's an overview that how blockchain works. And now we will see some more details. Okay, so let's talk about cryptographic ingredients of Bitcoin. So the first cryptographic ingredient is public key cryptography. As you may know, when we are talking about public key cryptography, we are considering two keys. One of those keys is public and the other one is private. So in this case, for example, the sender is trying to encrypt a message for Alex. So the sender needs to find the correct public key, maybe taking this key from the public key ring and get from there the Alice public key and apply a crypto system, and then in the output we will get the ciphertext. Then when the message comes to the other entity, the entity that is receiving this message, He will apply his private key, so Alice can recover the plain text. So that's the main idea about public key cryptography. And in blockchain, we will be using this kind of cryptography, but to sign, as we will see in some slides. So the other cryptographic primitive that we have to consider when we are talking about blockchain is hash functions. So hash functions takes as an entrance a binary string of an arbitrary length that comes from here, and then processes to get a digest. The digest is also a binary string, but small, with a fixed length. So the idea is that this digest can help us to verify the integrity of the message. What we have to do when we want to check the integrity of a message is to calculate again the hash function over the message and getting the new digest and compare it with the previous one that we get before. If these two digests are equal, we can say that the integrity is okay. But if something, if they are different, then something went wrong in some moment in the time. So, and then the other primitive that we have to consider is digital signatures. So using hash function, we can build these nice schemes, and these schemes tries to verify two conditions that are very important. One is the signer authenticity, and the second one is the document integrity. So how it works? Well, still we have the signer, we have the verifier. So the signer takes the original data and process by using a hash function, and we get a digest. That is the hash result. And then we have to sign by using a signature algorithm, and we have to use, the signer needs to use the private key. So
can you please be a bit louder?
Okay, you can listen to me?
Your volume is very low.
Ma'am, it's all right. Please turn on captions. It will be easy.
Is there anyone else who is feeling this the volume is low to be audible?
No, sir. Here with us, it's good, sir. It's good.
Okay,
We can understand. Yeah, we can listen, sir.
Taruk, there might be a possibility of some network issue with you. Dr. Rodriguez, I guess it's fine. Please go ahead.
Yeah,
Okay.
yeah, it's okay, man. It's okay. Yes.
Okay, thank you. And I'm sorry for the person that can hear me. Okay, I will try to talk louder. Okay, so what I was saying, that we have these digital signature schemes, and when you want to sign, you need to use the private key. So this allows to know that the signature, it was emitted by the signer, right? So in the insecure channel, what travels is the original data along with the signature. So the verifier has to compute again the hash function over the data. And with that, he will get a digest, and on the other hand, he can apply to the signature the verification algorithm by using the signer's public key. With that, we will have a second digest, and we can compare two of them. If they are equal, then we can know that the message is okay. So we can conclude that signer authenticity is okay, and the document integrity is as well okay. If something went wrong, then this will be different. These two digits will be different, and we can check that something was wrong, right? So that's the idea. As you can see, digital signatures are stronger than handwritten signatures, because usually when we stamp our signature, only signer authenticity is checked in handwriting, but not the document integrity. So these schemes are nice. Okay, so now we need to talk some other basic blocks, but we can consider Bitcoin basic blocks. So it's not more cryptography, it's just some interesting parts of the Bitcoin. So the first one is, of course, blockchain. So all the transactions done since the first Genesis block in January 2009 are stored in database nodes as blockchain. Transactions are ordered and marked with timestamps. So the idea is that every Bitcoin transaction is recorded in this database, and this database we call it blockchain. The blockchain has very nice properties and prevents the double spending problem and any modifications to the previous transaction. So the double spending problem is basically that I can want to spend a coin twice. So blockchain prevents that this can be done. Yeah, and well, Bitcoin client can store a copy of the blockchain in an independent way. If several nodes of the network have the same transactions in their blocks, we can say that the nodes are in consensus. So the blockchain needs to run also a consensus algorithm to decide which is the true history, right? And as of June 2021, the Bitcoin blockchain has a size of 342.96 gigabytes. So this can give you the idea that you need a lot of space to get your own copy of the blockchain. Well, but you can do this in general in cryptocurrency, and with that, you can start to do transactions, and also, if you want, you can try to mine a block if you are interested. We also need blockchain wallets. Wallets allow the generation and managing of private and public key pairs. So the idea is that a wallet has many addresses. And for that, you have to generate a key pair, and you can compute a hash function over the public key, and with that you will get the address for one of the address of the wallet. Wallets can verify transaction payments, and wallets can sign the transaction done through the accounts. So the idea is that my wallet will allow to sign when I want to make a transaction of money. So wallets communicate to the Bitcoin network, and they propagate the transaction that have been signed. We have to consider that there are hardware and software wallets, and mainly we can say that there are three ways to buy and sell crypto coins. One of those is to get a user password account in a specialized exchange application, or I can have a software wallet, but in that case, I have to be very careful with my private keys. I have to maintain them secure. And also, I can use a hardware wallet. This is the most secure option, but it's not for free, so I have to pay to get this hardware wallet. Okay, so the miners. Well, these are special nodes that help with the consensus algorithm. So the idea is that the transactions are accommodating a block, and the miners try to solve a cryptographic puzzle that is a challenge. And the challenge consists in produce a digits that start with some number of zeros. This number of zeros are called the difficulty. So the first Bitcoins were created by Satoshi Nakamoto on January 3rd of 2009. This was the Genesis transaction with 50 BTC. This action was executed in favor of an entity represented by Nakamoto's public key. This transaction is the first block in blockchain and is called the Genesis block. So the main idea is that after this block, we have many blocks where the transactions are stored, and these blocks are linked between them. So let's now talk about the Bitcoin transaction protocol overview. So let's suppose that Ali wants to buy 4 tacos in Bob's restaurant. As you know, in Mexico, we like a lot tacos. So to perform this transaction, Alice and Bob use the following procedure. First, Bob and Alice must have installed a wallet application. Then, wallets can generate and administrate the electronic addresses. Each address has associated to it certain balance of Bitcoins and a public private key pair. In order to sell the product, Bob must generate a new address to Alice. This new address will be used by Alice to send the payment to Bob. Alice needs to sign a transaction request using her private key, as well as the quantity of Bitcoins required to pay in Bob, and for paying a small tip to the miner. So basically, miners are happy and they try to mine blocks because they get tips from the transactions included in the block, and also they get another tip if they win and can solve this cryptographic puzzle that I just mentioned. So that's why miners wants to mine. Then, since this moment, any Bitcoin miner can verify Alice's transaction by using her corresponding public key, and eventually the transaction will be included in a blockchain. So this is the main idea of how Bitcoin works. But now I would like to talk about another attractive blockchain properties that we didn't mention it yet, that are used for novel applications that are different from cryptocurrencies. So, which are these attractive blockchain properties? Well, first of all, we have decentralization. The idea basically is that we don't need a third entity. For example, in the case of Bitcoin, we are putting out of the game the banks. So decentralization is possible thanks to the consensus algorithms that allow us to maintain data consistency in the distributed network. Another nice property that blockchain has is immutability. Each block is cryptographically linked with the next block. This makes that if I want to change some details of the transactions, this will be very hard, very difficult to do it. We also have anonymity. The idea is that each user can interact with the blockchain using an address which doesn't reveal the real identity of the user. So this is a nice property also. We have tamper resistance. As we have said, transaction in a blockchain cannot be modified. And we have also auditability. Each new node that is part of the network can get a copy of the blockchain and verify it from the Genesis block if this node wants. So these are the very nice properties that are required in novel applications. So let's talk about these novel applications based on blockchain. The first one is a supply chain. A supply chain is the set of steps required to produce and distribute a specific product to the final buyer. So the management of supply chain is a complex task that requires planning all different activities and logistics involved. And the idea is that we have to get a paper trail that should be produced and verified at each step to protect system from malicious entities that may force some of the proof. So here in the image, we can see that, for example, we can have a farmer that maybe have porks, and then we can distribute the pork, probably in a steak, from different parts of the pork, and it comes to the retailer, and finally the consumer can know about the origin of the steak that is going to eat. So the idea is to know from which farmer, for example, is coming the steak that I want to eat. So the idea is that we can use blockchain to trace products, basically. So let's talk a little bit more about what requires this kind of applications. So how to manage a supply chain based on blockchain? Well, the idea is that we can associate with each product a unique tamper-resistant code. And in the blockchain, I can record some interesting data about the product, such as price, date, location, quality, certification, etc. Also, by recording all the costly changes over the supply chain. So this is very important, right? Because we want to get responsibility of each of the activities. So imagine that someone gets sick after eating some part of the pork, right? So we want to trace all the way around to come this pork to my dish and see what was wrong in the process. Okay, so which are the benefits of the blockchain over this supply chain management? Well, ones that we will be interested on is increased transparency. The idea is that this immutable information stored in the blockchain will improve the traceability and the trust between the parties. Also, it will be easier to audit what happens. So any third party can verify the complete process and determine their correctness without costly inspections. Also, we can reduce management costs. Basically, as we can see in this kind of system, we have many different businesses that are part of the process. So having these controls is very expensive. And the idea is with blockchain, this is possible and we can do it cheaper. So let's see one case study. Well, basically, in October 2016, Walmart launched its food safety collaboration center on Beijing. The idea was to improve the way food is tracked, transported, and sold to consumers across China. The first food item to be tracked was precisely the pork. And the idea was to get farm details, batch number, factory and processing data, expiration dates, storage temperature, and shipping detail. And all this information is linked with the physical food items. So this is basically the image that I just showed you some slide before, where we have how it works, right? The Walmart project. But this Walmart project is not the unique solution. There are many initiatives regarding to supply chain management. One of those is Everlayer, that is active since 2015 and allows to store arbitrarily valuable products. Specifically, diamonds. The idea was to work with diamonds and check that how good is the quality of the diamond. Provenance is another company in which pilots experiment was tuna tracking in Indonesia. And we have some other companies that provide solutions for supply chain management based on blockchain, like BlockVerify, SweetBridge, and Facto. So there are many solutions that are proposed from companies. Also, there are some projects in academy where they are trying to tackle the supply chain management. So, well, I want to now talk about healthcare applications. So let's consider now how blockchain can help in healthcare. As you know, health information is considered personal data. The idea is that each patient produces a lot sensitive data, and this information needs to be protected and shared with different entities, such as doctors, pharmacies, insurance companies, etc. And we have to avoid unauthorized access. So this sensitive information about the patients is organized in electronic health records. So the problem is that these electronic health records are created by medical institutions with different formats that are often not compatible. So there are many initiatives to provide a solution of medical information and try to do something that is standardized. So let's see how blockchain tries to be a part of these solutions. So here we have pictures of the hospital environment. So as you can see, we have here the patient, and the patient has a lot of sensors that are monitoring different variables like blood pressure, blood sugar, and other things. And the idea is that this information needs to be shared with practitioners, with doctors, with pharmacies, hospitals, etc. And as you know, all this information is traveling many times through Wi-Fi channels. So, of course, we are concerned about the privacy and confidentiality of this medical data. So which are two requirements that I want to mention in this discussion. One is, as I told you, privacy and confidentiality issues. So if we see blockchain, the information or data that is stored inside the blockchain is visible to all other users. This is very nice in some applications, right? We say that this is transparency. But in the case of healthcare information, we need that the data is encrypted because we only want that some authorized entities can read it. So the solution is maybe use blockchain, but we have to encrypt the content in the transactions. Also, there are challenges because encrypted the information can be enough, necessarily enough from the legal point of view. So we have another problem, right? The public and the immutable nature of blockchain will mean that the encrypted data will remain forever visible. So again, this can be a nice property for some applications, but for healthcare information, this can be hard to manage, right? Why? Because if this information is always there, then some of these cryptographic algorithms used to encrypt the information can be broken. And then the content could be retroactively read, right? So blockchain needs to bring another security service, such as confidentiality, but it's not so easy to choose what to use, right? And the other requirement that is very important in healthcare application is the granularity. Storing all the information, medical information, it's not possible because the size, basically. Medical data contained in a record could include many images, and these images are space demanding. Also, we have to know that medical data keeps growing as the patient gets older, right? And on the other hand, in blockchain, we want that the blocks are lightweight because as we have explained it briefly, these blocks needs to be propagated in the network. So if we have heavy blocks, we will have a lot of latency and overhead. So this is not nice for the blockchain. So what the people is thinking as a healthcare solution based on blockchain is to have a system that stores medical personal records, and the control should be on their owners. So the owners are the only ones that can grant access to their records. So the idea is that I should say who can see my records and who cannot. And the proposed systems work all the same. They agree that what we have to store in the blockchain is only pointers to the medical data. So the idea is that this medical data should be stored in other place that is not the blockchain. So we will get some proposed solutions as a mix of two technologies, let's say blockchain and also cloud computing, for example. So the idea is that the cloud will keep all this big information, and in the blockchain, I just will record the pointers to this medical information. So the blockchain acts only as a decentralized secure system where users can manage the access to their personal records. So we have some projects also. For example, in Estonia, we have that there is a pilot that already manages electronic medical records based on blockchain. We have this other application called GEM that looks, these are their own words, a trade-off between personalized care and operational cost. And they try to connect the ecosystem by using blockchain. Also, we have Simple Digital Health, that is a decentralized application builder. So this is a nice initiative because you can build your own healthcare applications using blockchain in this platform. And they also provide a nice protocol called Health Nexus that helps to build these new applications. Okay, so finally, I will talk about another application that is electronic voting. So first of all, we have to think that e-voting may apply to many different voting systems, such as political, corporate decisions, or education authority elections. And indeed, e-voting is used already in many countries like Brazil, India, the United States, Belgium, Venezuela, Estonia, among others. So let's see how blockchain can be applied to electronic voting. So electronic voting is an application that has a lot of requirements. So here I am not trying to make a deep study. I just want to know, I just want to tell you why some persons and some companies and some academic people are trying to rethink these applications by using blockchain. That's the idea. So both.
Dr. Rodriguez, sorry to interrupt you.
Okay.
There's a question from Oas. Oas is asking how a normal user knows about the credibility of the node processing the data since everything is decentralized. It's in the message, in call message, if you can look at.
Okay, sorry, I didn't get the question.
Yeah, the question is how a normal user knows about the credibility of the node processing the data since everything is decentralized.
Okay, that's a nice question. Well, the first thing is that the node can be yourself. I mean, when, for example, if you want to be part of the Bitcoin network, you can just download this blockchain, big blockchain. Of course, you need a lot of space, but if you have it, you can download it. And then if you are like very, how can I say, you don't trust the system, you can even verify each of the blocks, everything to the last block on the blockchain. Then you will know that everything was computed correctly. And also, you maybe will get the sense that the software that you are using is correct, right? So after this, you will be informed of all transactions that are published for other users. Then that's the basic idea. The basic idea is that if we have many eyes that are looking how the system is working, then I can have more trust than in a centralized solution. If you think, for example, in traditional banks, right? You just trust that these banks are doing their work by checking that the transactions are correct, that if a transaction, for example, if you pay with your credit card, the restaurant trust that the bank is checking that the consumer has enough money to pay the bill. So what you are saying is that you are trusting to a third party to do that work. And the idea in the blockchain is saying, okay, I don't want to trust anymore in just one entity. I prefer to trust in the community. So the community will do this work. Basically, that's the idea. I hope this helped with the question. Okay, so I will continue, and I hope we will have many more questions. So now I will introduce electronic voting, and I was saying that electronic voting has a lot of requirements. So among them, we can mention the following. Votes cannot be tampered without the voting entity noticing. That's the idea. The voter should be able to check that each vote was cast as intended, recorded as cast, and tallied as recorded. Any outside observer should also be able to verify the election result. The voters should be able to prove to appropriate authorities that something went wrong without sharing any private information. Also, we need a system that is coercion resistant. The voters could pretend to cooperate with a malicious entity, and instead they will vote to their own choice. So these are some of the requirements, because electronic voting is a very nice application that you have to think very well each requirement that you need. But here we have like an overview of these requirements. So how blockchain can participate on e-voting systems? Well, the voting processes take place in three phases. We can consider voters registration, then we can consider vote casting, and finally vote tailing. So the idea is that in the voter registration phase, we need to verify that all and only entitled voters are allowed to cast a single vote. So that's the first step where we need to provide a mechanism to guarantee this, that you can just cast a single vote and that you have the enough credentials to vote. So what the blockchain solutions are doing is that you can send a token to the community and you can be part of a list that allows your address to later emit these votes. So during the casting phase, well, we need that the candidates advertise them as a set of address that representing themselves. So the idea is that we can have now a set of private public key that represents candidates in a specificity, and then each voter can send a token to an address to the choose candidate. So that's the idea. And then you need the tailing phase, and the idea is that you need to count tokens. You need to count all tokens received in some addresses, candidate address. So this is also just an overview. Still, we need to think in many problems that can arise in e-voting system, but that's the idea. For example, just to say one of those problems, imagine that if we are having an election, since we are recording everything in the blockchain, then that means that you can make the tailing phase on fly, online. So this is not a good idea because you can change the results of the election. So what you have to do is to have phases, right? So one of the problems that we need to think is how to solve this, just to mention one of the many problems that we have when we want to provide a blockchain electronic voting solution. But as you can imagine, there are many or some projects that are trying to have e-voting by blockchains. One of those are Open Vote Network, which is a decentralized self-tailing internet voting protocol that aims to provide maximum voter privacy. Follow My Vote is an open source project based on BitShares, that is a Bitcoin fork. Yeah, and this system allows for 3 different election types: proportional representation, mixed member, and majority. Another project is Agora Voting, aims to be a secure and transparent digital voting based on Bitcoin. So as you can see here, there are some projects regarding to electronic voting on blockchain. There are also many criticisms because yes, electronic voting is difficult to achieve a secure solution, right? But well, we can try, right? So as final remarks, I want to say that the most desired blockchain property for all considered applications is transparency. Blockchain is used as a trusted third-party repository. Despite being originally proposed as a way to remove third entities, so that's very curious, because what we want now is to use this blockchain like as something that everybody can see, but still is like a third party, right? Another benefit cited in all the applications that we have reviewed is the ability to lower cost. So this is also we can have a big discussion about this issue, because as you know, blockchain needs a lot of resources. Indeed, it's very expensive. So how is that we want to lower cost with something that is very expensive? So, well, we have to argue about it, right? So finally, I don't want to forget that there are many challenges about the blockchain itself. So all existent blockchain instantiations suffer from one of the following limitations. One is scalability. Scalability is something that is being researched a lot. Also, how to work with the overheads. That we have complex consensus algorithms, so like proof of work, right? That requires a lot of resources. Latency and throughput and many others. So the truth is that we have many ways to work about this research, right? There is people that are trying to make a more efficient and lightweight blockchain, and there are practitioners that are already proposing how to use blockchain for nice applications, such the ones that we have reviewed in this talk. So this is my contact information, and muchas gracias por su atención. Thank you for your attention.